Hello everyone, welcome you all. Let's start our discussion and derive these two important expression, that is divergence of position vector and curl of position vector in different coordinate system. देखो ये बहुत ही इंपॉर्टेंट एक्सप्रेशन है। ये चेक करना CSIR 2014 एंड गेट 2007 में ये एक्सप्रेशन आया है। Okay. So now let us derive these expressions in different coordinate system. Okay. So to derive these expression, divergence of position vector r and curl of position vector of r, we need to express the position vector r in different coordinate system and also the expression of divergence and curl in different coordinate system. Okay, so first let us write the general expression for this divergence and curl. Okay, so if you remember, you can directly write, but I am first here, I am writing the general expression for divergence and curl. Okay, so for divergence of any vector is given by 1 by h1, h2, h3, del by del q1, h2, h3, a1 plus del by del q2, h3, h1, a2 plus del by del q3, h1, h2, a3. Next, curl of any vector is given by 1 by h1, h2, h3, determinant of h1 e1 cap, h2 e2 cap, h3 e3 cap, del by del q1, del by del q2, del by del q3. Okay. Next, h1 a1, h2 a2, h3 a3. Okay. So now to write this expression divergence and curl in different coordinate systems, we need this h1, h2, h3, q1, q2, q3, and e1 cap, e2 cap, e3 cap. Okay, so let us write those. Thus h1, h2, h3, q1, q2, q3, e1 cap, e2 cap, e3 cap. Okay, now in Cartesian coordinate system, h1, h2, h3, 1, 1, 1, x, y, z, e1 cap, I cap, j cap, k cap. Then in spherical polar coordinate system, h1, h2, h3, this is your 1, r, r sine theta, q1, q2, q3, r theta phi, e1 cap, e2 cap, e3 cap, r cap, theta cap, and phi cap. Next, in cylindrical coordinate system, in cylindrical coordinate system, h1, h2, h3, 1, rho 1, rho phi z, rho cap, phi cap, z cap. Okay, so now using this, you can easily write that divergence of any vector A in Cartesian coordinate system is del y del x ax plus del y del y ay plus del y del z az. Okay, so here our vector is position vector. Okay, our vector is position vector, and position vector in Cartesian coordinate system is expressed as x I cap plus y j cap plus z k cap. Okay, so divergence of r in Cartesian coordinate system equals to del y del x ax component of position vector in x component of position vector, that is your x plus del y by del y plus del z by del z. So 1, 1, 1. So this is equals to 3. Okay. So divergence of position vector in Cartesian coordinate system is 3. Next, in spherical polar coordinate system, we have to write the expression of divergence and position vector in spherical polar coordinate system. Okay, spherical polar coordinate system. Okay, so here first let us write down the expression of divergence of any vector A. That is your 1 by h1, h2, h3. So this is your r square sine theta. Okay. Del by del r h2, h3. That is your r square sine theta. Okay. Then first component of that is your AR. Okay. Plus del by del theta. Then it is h3, h1. That is your r sine theta. Okay. Then a theta plus del by del phi h1 h2, that is your r a phi. Okay, so now here we have to find the divergence of position vector. So next we have to express this position vector in spherical polar coordinate. Okay, here now we have x I cap plus y j cap plus z k cap. This is in Cartesian coordinate system. Okay, now let us write this position vector in spherical polar coordinate system. So for that you have to express this x, y, z in spherical polar coordinate. And we know in spherical polar coordinate x is r sin थीटा cos phi. ओके देखो ये याद रखना है तुम्हें. ये कैसे आता है कि लेट दिस इज r. ओके द डिस्टेंस ऑफ point P from origin. Now this makes an angle theta with z axis. Okay. Now when we take a projection of this OP in xy plane, this is your x, this is your y. Now this is your OQ. This makes an angle phi with positive x-axis. So this projection value is देखो ये r z के साथ थीटा एंगल कर रहा है, मतलब यहाँ पे इसका मैग्नीट्यूड होगा r cos थीटा. तो ये प्रोजेक्शन का वैल्यू हो जाएगा r sin थीटा. अगेन ये r sin थीटा मेक्स एन एंगल I with x. सो x कंपोनेंट क्या हो जाएगा r sin थीटा cos phi. ओके सिमिलरली y इक्वल्स टू r sin theta sin phi. Z is r cos theta. Okay, so you can write the expression of x, y, and z here. Okay, so r equals to r sin theta cos phi. R sin theta cos phi I cap plus r sin theta sin phi j cap plus r cos theta k cap. Next, see. Now you can write this r vector as we can take r common, so r sin theta cos phi I cap plus sin theta sin phi j cap, sorry sin phi plus cos theta k cap. So r and this expression is of r cap. Okay, so you can remember directly that position vector r is expressed as r cap in spherical polar coordinate system. Okay, r cap. This is the expression of r cap. Similarly, you should remember the expression of theta cap and phi cap. Okay, so now we have the expression of divergence and position vector both in spherical polar coordinate. So our position vector r is r cap and divergence is this one. You can simplify this expression also. Here from here sin theta will go out. Okay, let me write that expression here. Divergence of any vector will be 1 by r square del by del r square ar plus sin theta. R will cancel out, so it will be 1 by r sin theta del by del theta sin theta a theta plus 1 by r square sin theta 1 by r sin theta del by 1 by r sin theta del by del phi a phi. Okay, so here you can see we have only a r component, that is r. A theta 0, A phi 0. Okay, so divergence of position vector r in spherical polar coordinate, that is 1 by r square del by del r square times r. Okay, so 1 by r square, take the derivative, it is 3r square, that is equals to 3. So again, divergence of position vector of r in spherical polar coordinate system is 3. Okay, next we will do in similar way for cylindrical coordinate system. Okay, for cylindrical coordinate system, again first we have to express this divergence and position vector r in cylindrical coordinate system. So divergence of any vector a equals to 1 by rho del by del rho s to s3, that is your rho a rho plus del by del phi s3 h1, that is 1. So a phi plus del by del z h1 h2, that is rho a z. Okay, now position vector r, this is your x I cap plus y j cap plus z k cap. Again, write down the expression of x, y, and z in cylindrical coordinate system. X is rho cos phi, y is rho sin phi, y, and z is z. Okay, so this is your rho cos phi I cap plus rho sin phi j cap plus z k cap. Okay, again, r equals to rho common, so cos phi I cap plus sin phi j cap plus z k cap. So position vector in cylindrical coordinate system is rho cap plus z k cap. Remember, in spherical polar coordinate system, position vector is only r cap. But in cylindrical coordinate system, this is rho cap plus z k cap. Okay, this is the expression of rho cap. Now we'll calculate the divergence. Okay, so divergence of r in cylindrical coordinate system. See, this is 1 by rho. Okay, so 1 by rho del by del rho. This is rho and a rho. This is rho. Okay, plus there is no phi component. Phi component 0. So we can directly write that to be 0. This will be 0. Now del by del z. Okay, plus 1 by rho del by del z rho az. Az is your z. Okay, so from here it is 1 by rho 2 rho plus 1. Okay, so 2 plus 1 will be 3. So again, divergence of position vector in cylindrical coordinate system is also 3. Okay, so in all coordinate system, the divergence of position vector is 3. Okay, next we will calculate the curl of position vector in different coordinate system. So now we have the expression of position vector. We know the expression, like in Cartesian coordinate system, it is x I cap plus y j cap plus z k cap. In spherical polar coordinate system, it is r cap. In cylindrical coordinate system, it is rho cap plus z k cap. Okay, so now we have this expression. Now we have to express the curl in different coordinate system. Okay, so let us write the curl. Curl of r first in Cartesian coordinate system, 1 by h1 h2 h3. For Cartesian coordinate system, h1 h2 h3 are 1 1 1. So determinant I cap j cap k cap del y del x del y del y del y del z. Again here x component, y component, z component. Okay, x component is x y, z. Now you can calculate the determinant. Okay, that is I cap. See, leave first row, first column, then del z by del y minus del y by del z. So that will be 0 minus j cap again del z by del x by del z. That will be 0 plus k cap del y by del x by del y. That is also 0. So it is 0. So curl of position vector in Cartesian coordinate system is 0. Okay. So curl of position vector in Cartesian coordinate system is 0. Next, in spherical polar coordinate system. Okay, we have expression of r, so we need to write the expression of curl only. So curl of position vector in spherical polar 1 by h1 h2 h3 1 r sin theta, that is r square sin theta, then r cap r theta cap r sin theta phi cap del by del r del by del theta del by del phi. Now r component, that is your r, then theta component 0, phi component 0. So again here you can also calculate the determinant easily, that is 1 by r square sin theta r cap. See, 0 0, so it will be 0 minus r theta cap, again 0 0 plus r sin theta phi cap, again 0. So again curl of position vector in spherical coordinate system is also 0. Next, curl of position vector in cylindrical coordinate system. In cylindrical coordinate system. So write the curl 1 by rho cap, rho phi cap, z cap, del by del rho, del by del phi, del by del z. Okay. So again here rho component, that is rho, phi component is 0, z component is z. Now again calculate the determinant 1 by rho cap del z by del phi 0. This is 0. So this is 0 minus rho phi cap. Again this is 0 plus z cap. This is 0. Okay. So again 0. So curl of position vector in cylindrical coordinate system is also 0. Okay. So here we can write the divergence of R in all three coordinate system, that is in Cartesian, spherical and cylindrical coordinate system is 3, and curl of position vector in all three coordinate system is 0. Okay, so remember. Next, you can check in GATE 2001, there is a question of Laplacian R. Laplacian of position vector in Cartesian coordinate system. This is 0 in Cartesian coordinate system. In Cartesian coordinate system. But you should derive Laplacian of position vector in spherical polar coordinate system and cylindrical. Okay, ये डिराइव करके कमेंट सेक्शन में लिखना, ठीक है। ये दोनों एक्सप्रेशन Laplacian of R in spherical polar coordinate system and cylindrical coordinate system. Okay. Okay, so let's stop here. I think this will definitely help you in deriving this expression. And if you found this video helpful, don't forget to like, share and subscribe to our channel. Thanks for watching. See you in the next one.